Okay, so what we need to do first is just a quick refresher on Pythagoras' theorem. Okay, so the Pythagorean theorem states what? You want to know? What's it about? Well, not just a squared plus b squared c squared. I mean, it isn't on the board in front of you. But so we've got a what type of triangle?
Right angle triangle.
Okay, we've got a right angle triangle. Okay, sorry, my drawing's not very good. Do any of the sides matter, or could they all be A, B, and C? They could all be A, B, and C.
No, it's left. Yeah.
So I tell you what, I'm going to add it another level. Let's just check your understanding. If I say P, Q, and R, what is Pythagoras' theorem? Yeah.
Q plus R. Yeah.
Not quite. Daniel?
R plus Q equals P.
Nope. I think that's the same thing. Michael?
Q plus R equals P.
No, that's, we said that. Is it?
Q squared plus R squared.
P squared.
Oh yeah.
Yeah? So it's not about the sides of the triangle, it's about the squares that were on them, yeah? Does that make sense? And it's important that it doesn't matter what the letters are, because normally we say it's A, B, and C, where C is the hypotenuse, yeah? Yeah.
Wait, isn't C usually the value that's not like set? It doesn't always have to be the hypotenuse.
Sit down. We're talking about things that went badly in the test, so you can benefit from this before you take it. Alright, so, what was the question? C is the one that...
Isn't C the usual... Isn't C usually the value that's like not, like usually X?
Okay, well this is the problem. Alright? C, when we start with Pythagoras' theorem, normally we take the two shorter ones, square them and work out the longer one, right? That's what we've been doing. So if I gave you a question, for instance, and I said, if I make it really simple, just roughly sketching. So I said, if that's 6, that's 7, this would be x, okay? Pythagoras' theorem would state that is x squared. Good. Okay. Make sense? So x squared would be, well, 6 squared is 36 plus 49. Well, that will equal x squared. So 36 plus 49 is 85. That will be x squared. Okay. So what would x be? Good. The square root of 85. Is there anyone that doesn't understand why that's the square root of 85? Okay, good. So the square root of 85, if I was going to use my calculator, what would that be? .22. So we're saying it's 9.22. And that kind of makes sense, right? Because if that's 6 and 7, you'd expect it in roughly the same idea. Yeah? If I were to give you another one then. Okay, what have I done to the triangle?
Just turned it.
Turned it a bit, yeah? So we've got to be careful. This is where some people made mistakes. Not everyone made this mistake. Some people made this mistake. Okay? We turn the triangle round and you get suddenly the hypotenuse changes. The hypotenuse is not always on the top. The hypotenuse is always the
longest side.
Longest side.
Or opposite.
Or opposite the right angle, exactly. So take the right angle, draw the arrow away, that's your hypotenuse. So in this case, Pythagoras' theorem is 8 squared plus 13 squared. Okay, so 64 plus 169. 233. Therefore, x is the, which is 15.3 then, yeah? Do we just check? Do we think that's right? It should be the longest side, right? Because it's the hypotenuse, so it should be longer than either of the other two. Is that making sense? Does that remind you of Pythagoras' theorem? Yes, sir.
The way you can avoid this would be by doing the angle thingy with trigonometry. So the reverse 10 or with reverse.
Yeah. So I tell you what, it's
That's
good.
easier.
It's funny. It's not easy. It's more than one step. I'll talk about it in a sec. Go on.
So if we start at 23, that's wrong. I mean 233.
If you left it as 233, or do you mean left it as the square root of 233?
Yeah.
If you wrote just the square root of 233, yeah, I'd be okay with that. Unless the question says, give your answer to one decimal place.
No, like not even for 15.3.
Oh no, if I put that, x squared is 233, you're not finished. If you wrote this line here, if I haven't written give your answer to one decimal place, actually this is a better answer because this is the exact answer and this is a rounded answer. So actually, as you get further on with your maths, quite often we want to leave it as the exact form. However, if I say in the question, which a few of the questions did, round to one decimal place, round to 3 significant figures, then you have to turn it into a decimal. Okay? So on your calculator, you've probably got an x squared button or something like it, and above it you'll have a square root button.
It's in blue.
Yeah. And then just put the number in. Yeah. So, as Owen was saying, by the way, I did see someone, and it wasn't Owen because he didn't take it, try and work out questions by, first of all, working out the angle using tangent, because I've got the opposite. So what someone would have done is say, well, this is an angle. I can work that angle out by using those two sides and tangent, because that's the opposite and that's the adjacent. I'll then use that angle, once I've found it out, to work out this side using sine or cosine. Okay? It's a different way. It's longer because you've got two things that you do. You need to solve two things. But it's fine. If you want to do it that way, absolutely fine. But it will take longer.
I'm just going to add all that.
Yeah?
The reason I do it is longer, much longer, but it's less complex than all of that, I think.
You think? So I think Pythagoras' theorem is easy. Because, for instance, does everyone want to have a go at doing what you're saying? Or are you kind of going, actually, no, if you get it, you do it? Should we just not bother? I don't think I would. Because to be honest, I've written on people's papers, and you'll see it when you get them back eventually. On this kind of question, I have written on it, no angle, use Pythagoras' theorem. Yeah? If there's an angle given in the question, I need to use trigonometry. So that's, for me, that's what I would say. Pythagoras' theorem is useful when we don't have an angle. If I have an angle, then I'm probably going to have to use trigonometry. Yes, ma'am?
It was one question that had just one number, and it was saying it didn't have an angle either, it just had one number on one side of it, and it said, 1, 2, 3, sigma.
I think you must have missed something in the question then.
That
It was a feast, I think. Now, none of the questions were impossible to answer.
And it said figure out half of what it was, and it was an 8 on the
Oh, so maybe it was, you know, it's a certain type of triangle. Yeah? Michael?
How can you, when the triangle is split like that, how can you figure out which one is the adjacent and opposite?
Right,
It's the same
a
thing.
good question. No, actually, there's only an opposite and an adjacent if we have an angle. So when we do Pythagoras' theorem, there is no opposite and adjacent. The only thing that matters is that we get the C correct, yeah? The hypotenuse, that's the one to identify. You've got to say, well, that's the hypotenuse. That's all that really matters. All right? If there's an angle, then we worry about opposite and adjacent. And we're going to do a bit of that after we've done Pythagoras' theorem.
But how can you tell which side is the angle?
What do you mean, which one's? The 90 degrees?
No, like how there's the side on the left and the right. How could you tell which one?
What, for Owen? The way Owen wanted to do it?
No, like when.
Yeah, but for this question, there is no angle. I've not given you an angle. I'm not going to ask you to find an angle. If I said to you, so for instance, do you all get that this question I'm asking you to find the third side, yeah? I could give you the same thing, alright? Let's say, got the same question like this, and it's, what was it, 8, 13. Alright, so that's the triangle I gave you. So if I said to you, find x, we would do what we did before, alright? I would use Pythagoras' theorem. But if I change the question and say, find theta, now what kind of question is it?
Trigonometry.
Trigonometry. So now I'm telling you which angle to use.
So no question would be find the angle if there wasn't an angle.
Exactly. Yeah. So, next stage for me to do, so that was generally not too bad, but here's the important bit. Here's where everyone made their mistake. Okay? And it's got nothing to do with how the triangle is laid out. Okay, sorry, I'm not drawing the very well. The right angle triangle. And what if I said to you, x 15, 5? Now almost every single one of you did the common mistake that lots of people do in the world when they first learning Pythagoras' theorem. What they do is this, they say a squared plus b squared equals c squared. You all wrote out, great, love that, because you're showing your, that's good, that's fine. But then you did this, you said 5 squared plus 15 squared equals c squared.
Yes.
And you said 25 plus 225 is c squared, and then you got 250 c squared. So c is the square root of 250, which is what on a calculator? Just tell me. Don't tell me what I've done wrong there. Calculator. Anyone? Put your hand up if you've spotted the mistake. Spotted the mistake. Okay. 15.8. Okay, let me just put that on my diagram. Because remember, I've always said that. 15.8.
That's bigger than the hypotenuse. And it's
Exactly.
bigger than the hypotenuse because that is shorter than the hypotenuse.
Exactly. 15.8 is longer than the hypotenuse.
Because 15 is the hypotenuse.
Exactly. 15 is. Remember, I said the first thing to do is identify the hypotenuse.
So then, that's all.
No. You do have to show X.
So,
But if you're whatever you get is bigger than the hypotenuse.
so we've done something wrong.
You don't use.
Thomas.
You can't do 5 squared plus 15 squared equals c squared. It has to be, I forgot which side you do, but it's like either 5 squared or 15 squared. But it's like c squared plus 5 or 15 squared.
No, not quite.
And you flip it and you subtract.
Not quite. We don't rewrite Pythagoras system. Pythagoras system stays as it is. What do we
So
do?
you put the hypotenuse as a or b, and it's supposed to be.
We've all,
It's
yes,
supposed to be 5 squared plus x squared equals.
exactly. That's it, isn't it? Do you all get that? What we've got to do is fill in Pythagoras' theorem with the correct values. What all of you did was just go up 2 numbers, add them together. That's what I've got to do, work out the one that's not a number. So what we do is we fill out Pythagoras' theorem and we say, well, A and B don't matter, do we? What matter was that C has to be 15. So we've got 15 squared equals, well, the other two don't matter, so I can do x squared plus 5 squared equals 15 squared. So this is where I'm saying yours wasn't quite right, Thomas. I don't rewrite it, okay? Is it what? No, there's no angle. I'm not doing trigonometry. If you just think about what it is, do you remember the whole point of Pythagoras' theorem was the 2 smaller squares
Should equal the one big square.
equal the big square. Therefore, what I've been told is the big square and one of the smaller squares. So if I take the big square and I subtract out the little square, I'm left with
The other square.
the other square. So actually what I do is this. I subtract the 5 squared. So x squared is 15 squared, subtract the 5 squared. Okay? So this is where the whole understanding that Pythagoras' theorem is all about the sizes of the squares add up to make the big one. So if I know the big one, I need to subtract one of the little ones to leave me with the other little one, yeah? Let me put it another way. Thomas and Nick add their money together, all right? And that tells them how much they can afford to buy. Yeah? Daniel? All right? So Thomas has 10, Nick has 20. How much can they afford to spend? 30. Let's put it another way. I know that they have 50 to spend. Nick has 10. How much does Thomas have? Why? 50 minus 10.
That's why I said 10. I said 20.
Oh, I thought you said 10.
No, 10.
Oh, right, that's why I said, did you say 10? No, it's still not 10 though, is it? But do you understand how if the 2 smaller things, their money, add to make the bigger one, then if I know the bigger one and one of the smaller things, so I know how much they've got to spend, and I know how much Nick has, I've got to subtract it to figure out what the other smaller one is. Yeah? Go on.
Test for that questions like that one, I did the minus. I think I just wrote it with C instead of X.
Well, if that's what you know, then you'll do it better next time. Okay? Right, so the answer then is x squared equals 225 again, minus 25. So x squared is
200.
200. So x is the square root of 200. And on my calculator I get
No.
No.
14.14.
14.1. Okay. So now if I put that in, does that make more sense? That make more sense?
Yeah, much.
Okay. So that's the big thing. It's the common problem. You need to make sure that's in your notes and you need to review that. Because that's what you've got to do. Yeah.
Do you only use it when x is the opposite and adjacent, or?
There is no opposite and adjacent because there's no angle. So, if one thing, maybe a one way to write it in your notes is, if you want to find the shorter side, you have to subtract. Shorter, subtract. Yeah? Longer, add. Yeah? So find the hypotenuse, you add them together. If you want to find one of the shorter two sides, you have to do the subtraction. Well, I can, but what I want to do is go to the next thing, and you can review these afterwards, and maybe one more lesson you can review both. Because some of you might feel, actually, yeah, I do know that, but some of you not. Right, I will give you some more, but because we've only got, what, 15 minutes? I'll tell you the next thing. This one is another very common thing, and you might find this one a bit more tricky to get your head around.
Do not erase it, please. Do not erase it. Thank you.
Don't forget, this is on a video and will be on the YouTube channel. You can always go and review it and watch it if you don't fit. Okay, the next problem is with trigonometry. So that was the only issue with Pythagoras' theorem. Apart from when you have to apply it, drawing the diagrams and things, that last question, no one really got that. And that was a double Pythagoras theorem one. So you had to do it in 2 stages, right? Like I said, the end ones are more complex. But now we need to look at the trigonometry questions. So with trigonometry, what are you expecting to see in the triangle? An angle. Okay? So it's obviously a right angle. Okay? Let's say I've got an angle of 50 degrees. Got 50 degrees. Right? Which one's which? This one?
Yeah, that's the opposite.
This one's the opposite. This one's the. This one's the hypotenuse. Can I just say, one person in here got answers correct, but they did 2 things wrong that cancelled each other out to give them the right answer. Because the way we mark with NYP with criterion-based stuff, you don't get credit for that. Okay?
Can you repeat that?
So if you make a double mistake that cancels itself out, and you get the correct answer.
How do you do that?
Well, in this case, in trigonometry, it's quite easy because if you get the ratio the wrong way up, all right, and then do the next bit, which everyone else got wrong as well, and you do it the wrong way round, the wrong way up and the wrong way round cancel each other out to make the right thing. Okay? So, I went through the answers and I ticked and went, oh, she's the only one that got that. Oh, right. So the problem with this one then, this question, I tell you what was good. Chad, I'm gonna say, and you're gonna look stroppy at me, and alright? Can't talk while you're talking. Right, the problem with this, what was great was the fact that everyone set out their solutions really, really well. Okay? So you all had your SOHCAHTOA, you listed it out. That was great. The problem came with something we obviously hadn't done enough of. So for instance, if I tell you some values, for instance, so if I say I want to know the opposite side, right? And I tell you that the hypotenuse is 11. Okay? So on this triangle, I know the hypotenuse and I know the opposite side. No, sorry, I want to know the opposite side. So I put my SOHCAHTOA, right? I put my theta, opposite, adjacent, hypotenuse. You're all used to seeing this. Theta is 50, the opposite is x, the adjacent, the hypotenuse. Okay? So which one am I going to use? Get rid of that because it's got an A, get rid of this because it's got an A, so I'm using this one. So this was the kind of question everyone did really fine, brilliantly. Okay, you've got x divided by 11 equals sine 50. So what do we do to find the x? Times it by 11. So we did 11 times sine 50 equals x. One person carried on a mistake that they'd done for a piece of homework and forgot to do the 11 times bit. Not you. Alright, so they just did sine 50 and it was like 0 point something and they forgot to times by the 11. Alright, and that was their final answer. I remember them doing it for homework. So, that's correct, isn't it? Everything we've done, absolutely fine. Here's the problem then though. If I were to give you a different version, and it wasn't anything to do with the way the triangle was, so I'm not going to worry about that. I'm just going to draw the same one. You all know how to find the hypotenuse and stuff. But what if I did this? Okay? So this time, I'm asking you to find the hypotenuse and using the adjacent. So, SOHCAHTOA again. Eventually we'll stop having to write all this out because you'll be like, yeah, I know it. I know which one it is. Theta is 45. Opposite. Don't care. Adjacent 7. Hypotenuse x.
Cosine.
Cosine. Because I'm not using anything with an O. So then, one thing, some people just put cos and then numbers. We have to do cos of the angle, which is cos of 45. Alright? That equals what?
7 over x.
7 over x. Adjacent over hypotenuse. Okay. Now, this is the point where, so people got to this. Great, fantastic. Okay. After this, they did something illegal, mathematically illegal. They picked it up and they moved it. They picked up the 7 and they moved the 7 and they did this. They wrote 7 times cos 45 equals x.
Yeah, I don't see why that's wrong.
I can explain this.
I'm just trying to think back. I don't see why that's wrong.
Those people that can't see why that's wrong are not saying to themselves what is actually happening.
Okay, so
pay attention.
in this question, what you have to do is multiply by x, and then the other side would become 7 over cosine 45, or on your calculator, 7 divided by cosine 45.
Yeah.
Yeah.
Right, so what we do is we've got to say to ourselves, I want to know x. Okay? I want to know x. On this side is where x is. But what is x doing? It's what I'm dividing by. It's 7, guys. It's 7 divided by x. Okay?
Yeah.
So, if I pick up the 7 and move it to the other side, what am I left with on the other? I'm not. I'm left with nothing divided by x.
Oh.
That That's because what you're thinking of it is, you're thinking of it as a 7 over x. So you're thinking, well, if I just take the thing that's on top of it, like if I have a building and I take away the top story, or a cake and I eat the top layer, I'm left with the bottom layer. Makes sense. But in maths, it's not like that, is it? It's 7 has been divided by x. How do I sort that problem out? Well, there is one way to do it, which is if you think of it like as another easy problem. For instance, 8 divided by 2 equals 4. Right? Say something else that's true, using those 3 numbers. 8 equals 4 times 2. Or 8 divided by 4 equals 2. Alright? Now, because cosine of 45 is just a number, it follows. Are you with me, Sasha? Doing something else? Yeah. It follows that this follows the same rules as this. So if cos of 45 is 7 divided by x, right? I can also make the same statement. Not this. This makes absolutely no sense. That's like saying 8 times 4 equals 2. Alright? Which just isn't right.
No, times 4 is.
So what we have to do is, remember I said, guys, settle, this is important, Daniel.
Yes.
So, I'm going to write it again. Cos 45 is 7 divided by x. So what I do first is the times by x to get rid of the divide by
And you
x.
times by x on the other side.
So I get left with x times cos 45.
Yes, and then you cancel out the cos 45.
Right, this is one problem that I think someone else did. Alright? Which is, alright, they then divided by, and someone did divide by cos.
Yep, no, I did cos 45.
Alright? And they cancelled out causes but left the
No, I'm
angles.
good, I'm good.
A couple of people, right? But we divide by cos 45 and we are left with
What?
x equals 7 over.
Cos 45.
Now I know that I taught you this because Safia's going to remember.
You just switched cosine next.
Remember we said the shortcut that I don't like you relying on looks like the cos 45 and the x swap positions. Okay? In the same way that with the 8 divided by 2 is 4, 8 divided by 4 is 2. The 2 and the 4 look like they switch positions. Alright?
I didn't switch it, I just did 7 divided by cos 45.
No, that's correct. But what I'm saying is, it looks like they just swapped. Alright? They haven't just swapped, but it looks like it. So, Daniel, come back to the room. Focus.
Oh, yeah.
Right, we'll stop going in your bag. This is what you were getting wrong on your test. Alright? So this, right here, was the second thing that happened. Now, it wasn't just with cos. There was also tan. Alright? A couple of people, this wasn't an everyone thing, but a couple of people got their opposites and adjacent sides mixed up. Alright? So the opposite was adjacent and adjacent was opposite. But you know that, we've talked about that. You know that's a possibility. So I said be very careful. So if that's a practice thing you need to practice, make sure that you know the opposites and adjacents. But we only have opposites and adjacents when we have a what, Jalen? In the triangle, it will only have opposite and adjacent sides if there is an angle. Okay, we've said that over and over again. Okay, if there's no angle, we're going to be using
Wait, what?
Pythagoras'
theorem.
Yeah.
I can question.
Okay, listen, come. Owen.
So then, how can we find the theta if there is no angle?
Well, you won't be asked to.
So then,
So if I ask her a question and I ask what the side length is, I'm asking the side, I don't need the angle, yeah? If I give you an angle and want to know the side, you're using trigonometry. If I give you the sides and ask you what the angle is, you work out the angle. If I give you the sides and ask for a side, you're going to use Pythagoras' theorem. You use the tool for the job. Now you can, like you said, and at least one person did the same thing you suggested, which is use trigonometry to find the angle to then use trigonometry to find the side. Okay? Which is fine, but the more steps you take, the more chance there is of making a mistake and rounding. Okay? But they were the main issues. There were other issues for a few people with identifying the angle of depression and things like that in the right place. Okay? There was, to be honest, the drawing the things with the kites and where the boat was, you were better than that. Better than my M5s at doing that, on the whole. Only a few of you got the angle of depression wrong. How do you know what the angle of depression is?
It is.
We don't know.
Looking down.
Yeah, you look out and you look down. It's not necessarily in the triangle, is it?
No.
So you draw that on your diagram first and then work out where the triangle is. The final questions on the test, you know there's going to be more than one step to it. It'll be identify the triangles. Is it do Pythagoras' theorem once, then do trigonometry? Or is it Pythagoras' theorem, then another Pythagoras' theorem? But we've done questions like that where you have to work out one side to work out the other. A lot of people on that first question, the double triangle one, actually approached it really well, but did this wrong. So got the wrong middle line and got the whole thing wrong. Okay? So that's why I'm telling you, those are the two things to really focus on. Okay? Next lesson then, what we'll do is we'll go through some examples.